Hello, Geometry Advanced students. So today we are going to, again, continue our study of area, but we are going to look at ratio of areas. So as you can see here on my screen, my two objectives are to find the ratio of areas by calculating and comparing the areas, and to find the ratio of areas by applying properties of similar figures. So if I take a look at the first picture, it says we're given that we have circle O, that segment AB is 8, and segment BC is 6, and it says to find the area of the shaded region. So what I would do, if I'm thinking this through, again, we just finished the previous lesson on areas of sectors and areas of segments, things like that. So what I would do in general is to take the area of the semicircle and subtract off the area of triangle ABC. So since a semicircle is half of a circle, I could do half of its area. Now, in order to find its area, I need the radius. But we know from a previous chapter that any angle inscribed in a semicircle is a right angle. So that means that angle B here is a right angle. So using a multiple of my Pythagorean triples, so if I have one leg is 6 and one leg is 8, that's a multiple of the 3, 4, 5 triple. So that tells us that the diameter of the circle is 10, which implies that the radius is 5. So for the area of the semicircle, I'm going to do 1/2 of pi r squared, and again my radius is 5. So that would be 1/2 of 25 pi, or if I want to think about it, 25 pi over 2. Now again, I got to subtract off the area of a triangle. Area of a triangle, again, from our previous lesson, is 1/2 base times height. The base and the height are the legs in this right triangle. So I want 1/2 of 6 times 8. 6 times 8 is 48, and half of 48 is 24. So again, my final answer would be 25 pi over 2 minus 24. Okay, so just a quick review there on area. So continuing on here, and next it says find the ratio of the area of the parallelogram to the area of the triangle. So we need to find each one and then write it as a ratio and then reduce if it is possible. Okay, so if I look at the parallelogram first, area of a parallelogram, remember, is base times height. So it looks like the base is 9 and the height is 10. So 9 times 10 is 90. Next, if I do the area of a triangle, again, that's 1/2 base times height. The base is 12 and the height is 8. So that's going to give me, what, 48. So again, I want the area of the parallelogram to the triangle. So I'm going to put the parallelogram on top, 90 over 48, and then I want to reduce. This is reducible. 90 and 48 are divisible by, let's see here, how about 6? 90 divided by 6 is 15, and 48 divided by 6 is 8. So that's going to reduce to the ratio of 15 to 8. And if you want to write it this way, is 15 to 8, or write 15 to 8. That would be all acceptable. So again, the title of our lesson for today is Ratio of Areas. Okay, so let's continue into this part. It says find the ratio of the area of triangle ABD to triangle CBD. So again, what we're looking at is triangle ABD. I'll highlight that in yellow. And then let's switch colors here. Triangle CBD, I'm going to highlight that in pink. Well, again, area of a triangle is 1/2 base times height. So if I do ABD first, so I don't know the height. So let's draw it in and call that H. So it will be 1/2 the base, which is 5, times the height, which is H. In the pink triangle, triangle CBD, I don't know the height either. But notice the heights are the same. Since that's an obtuse triangle, the height is still going to be the H. My base would be 2, and again, the height would be H. So when I reduce, so looking at it before I even make any reductions here, notice there is an H in the top and the bottom, numerator and denominator, so that's going to reduce out. They both have a 1/2, so my ratio of the areas is just 5 to 2. Well, 5 and 2 are the bases. So my connection here, like it says, notice these two triangles have the same height. So if they have the same height, the ratio of the areas is just the ratio of the unequal parts, like in this case, the ratio of the bases. Okay, so now let's go to a little different situation here. Now it says find the ratio of the area of triangle ABD to triangle CBD. So if I'm working this one out here, so let me grab my marker here. So the ratio, so area of triangle ABD, so that's this, maybe I can color it here in pink. So area of a triangle is 1/2 base times height. The base is 20, the height is 10. In the triangle CBD, the one at the bottom, so let me just highlight that one in yellow. The base is still 20, but this time the height is 7. So before I even multiply anything out, you know, things will reduce. The 1/2 in the numerator and the denominator will cancel out. The 20 in the numerator and the denominator will cancel out. I'm just left with 10 to 7. So like it says here below, notice the two triangles have the same base. So if they have the same base, the ratio of their areas is the ratio of their heights, which would be the ratio of their unequal parts. So again, just a connection to make. So these are ones that are, we just looked at two of them, where the triangle has the same height in the first example I looked at, and the second one here now, they have the same base. What I have left to look at are your similar triangles. So remember, similar triangles, similar means they have the same shape, they're different sizes. Specifically with triangles, their angles have to be congruent and their sides are proportional. So if triangle ABC at the top there is similar to triangle DEF, find the ratio of the areas of these two triangles. Okay, so it would be 1/2 base 1 times height 1, and then 1/2 base 2 times height 2. So if we look at the theorem on how to approach this, okay, if two figures are similar, the ratio of their areas is equal to the square of the ratio of corresponding segments. So in this picture, the corresponding segments, it looks like, are 15 and 10. So if I write 15 over 10 as a ratio and reduce it, 15 and 10 are both divisible by 5. So that would be a 3:2 ratio. And again, I have to square it. So if I square 3:2, the ratio of their areas is going to be 9:4. So again, if they are similar, the ratio of their areas is the ratio of the corresponding segments. Now, corresponding segments could be sides, could be altitudes, could be medians, could be diagonals, or could be radii. It could be any of those. So like, for example, if you're talking about circles, you're looking at the radius, or for that matter, the diameter. Okay, so in the next two examples, it says in the first one, the area of triangle MAP. So again, MAP, if I do a little color here, would be this yellow one. And MRT, let's see here, MRT would be the big one. So again, they are similar. We've got parallel lines in the picture, so corresponding angles are congruent. So if they are similar, we want, again, the ratio, we're going to do the scale factor, basically, the ratio of corresponding segments squared. So MAP is the little one, so that has a side of 6. The big triangle, in pink there, has a corresponding side of 8. So first off, I'm going to write 6 over 8. So like I was saying, you want to reduce 6 over 8 first. That gives me 3/4, and again, I have to square that, so that's going to be 9 to 16. So it's kind of like saying the little triangle has an area of 9, and the big triangle, let's switch colors here so it's easier to see. So again, the big triangle would have an area of 16. So that leaves us, in general, what's 16 minus 9? Hopefully you're going to say 7. So in the next problem, it says the area of the trapezoid TRAP, which is, let me switch colors one more time here. That would be this one here, to triangle MAP. So that would be look at the figure here. We had the 7, and then MAP was 9, so it would be 7 to 9 ratio. Okay, so let's try more examples here. So it says the apothem of a regular hexagon is 6. A side of another hexagon is 6. Find the ratio of their areas. Okay, so since they are both regular hexagons, they are similar. So to find the ratio of their areas, we just have to find the same corresponding part for both. So for instance, let's find the apothem for both. So in the second hexagon, if I draw in the apothem, it's going to split this side into 3 and 3. And again, remember, this makes a 30, 60, 90 triangle. So if this little segment is 3, that means your apothem is 3 root 3. So if I want to find the ratio of their areas, I would put 6 over 3 root 3. That's going to reduce to 2 over 3 root 3. Now remember, we can't have a radical, or let's just leave it at this. Because we have, since they're similar, we have to square it. So 2 squared is 4, and root 3 squared is 3. So this is a 4 to 3 ratio. What I was starting to do is to eliminate the radical in the denominator, but knowing that we're going to square it, it's going to go away once we square it. Okay, so if I look at the second one, it says find the ratio of triangle ABM to triangle ACM. And it says that AM is a median of triangle ABC. So remember, a median hits it at the midpoint. So that means these two segments here that I just traced in purple are congruent. So since they have the same height, the height of both triangles is this orange segment here, the ratio of their areas is just the ratio of the bases. Well, since BM and MC are going to be congruent, that is just a 1-to-1 ratio. No matter what number they are. If you picked 5 and 5, 5 over 5 is still 1-to-1. If you picked 10 and 10, they'd still be 1-to-1. Because again, I'm looking at it as a ratio. Okay, so a median of a triangle, remember, hits at the midpoint. So in terms of area, it's going to, like it says here, divide the triangle into 2 triangles with equal areas. So in this picture, if segment PM is a median, that tells us that the area of triangle PMN, so that would be the triangle on your left, is equal to the area of triangle PMQ, which would be the pink triangle on the right. So their areas are on a 1-to-1 ratio. So for today, we have a book assignment you are going to do on page 546, like it says here, numbers 1 through 11. If you have any questions, again, please let me know.